The Chemistry Quest.
Children's book, Lightwaves and Energy by Marshall Branch.
And Stephanie Huisman. Chemistry, Midler, Period 1. Once upon a time, in a land far, far away, there was a prince named Philip. Philip had it all. He was rich, famous, and athletic, but he was horrific in chemistry. His mother, Queen Christine, threatened to banish him from the land if he didn't improve his chemistry skills.
So he set off on a dangerous quest to solve his troubles across the Gallium Sea to see what he could learn. Prince Philip had been on his voyage for 3 days when his boat began to shake.
All of a sudden, he saw a big yellow creature appear in front of his boat. It was Seaborgium, the sea monster. Scared, Prince Philip began to row his boat away when Seaborgium exclaimed, "Halt! I will teach you 3 things about chemistry. Pay attention and follow me. I will show you where you need to go."
Philip asked his new sea monster friend to teach him about electromagnetic radiation. He even included a chart about it. Seaborgium told him that it was
the wave nature of light. Electromagnetic radiation is energy that exhibits wave-like behavior as it travels through space. Examples are microwaves, light, and UV rays. Light is formed of electromagnetic radiation. Visible light is the very narrow part of the electromagnetic spectrum we can see. All types of light travel in a wave-like form.
Next, he taught Prince Philip about wavelength. Wavelength on a wave, the distance between 2 crests or troughs. The symbol is the lambda. Units, distance, meters or centimeters.
Wave part, crest, location, highest point on a wave. Wave part, trough, lowest point on a wave. Origin, midline of a wave. Wavelength. On a wave, the distance between 2 crests or troughs. The symbol is the lambda. Units, distance, meters or centimeters.
The third and final lesson Philip learned from Seaborgium was about frequency and amplitude. Frequency is the number of wavelengths to pass a given point in 1 second. The symbol is F. Units, hertz, Hz. Amplitude is the wave's height from crest to origin or origin to trough. Units, displacement, meters or centimeters.
Amplitude, wave's height from crest to origin or origin to trough. Units, displacement, meters or centimeters.
Then Seaborgium told Philip in his cave, "I have taught you much, but you must now go learn from the dragon of the land of Europium to continue your quest."
Philip then met the dragon, which with a roar said, "I will take you to the land of Euporium and teach you 3 more things about chemistry."
Philip then asked how to calculate the speed of light. The dragon taught Philip that all forms of light travel at the same speed, 3.0 times 10 to the 8 meters per second, denotated by c. This can be calculated by the below equation, which is true for all forms of light. C equals lambda times f, or frequency.
Wavelength and frequency are inversely related. As wavelength increases, frequency decreases. As wavelength decreases, frequency increases. Dragon included some practice problems for Prince Philip to look at.
Here's an example that Dragon included to show Prince Philip about what he was going to teach him next, the concept of the quantum.
Then Dragon told Philip about the concept of the quantum with a fiery breath. The concept of the quantum was developed by German physicist Max Planck around 1900. He proposed that a particle can gain or lose energy in only a small distinct unit called quanta. Singular is quantum. The energy of the wave photon is calculated by multiplying the frequency by Planck's constant. Energy is directly proportional to the frequency of light. The Planck-Einstein formula is E equals x times F. E equals energy, units joules, H equals Planck's constant, 6.63 times 10 to the negative 34th seconds per joules. F equals frequency of radiation, units hertz.
Last, but certainly not least, Dragon taught Philip about the photoelectric effect. In 1905, Albert Einstein, referencing the photoelectric effect, proposed that light also behaves as a particle, which he called a photon. Photoelectric effect. Many pure substances, when exposed to visible UV or higher energy photons, emit electrons. Light behaves both as a wave and a particle. Properties of a wave. The entire electromagnetic spectrum. Light can be bent and redirected or refracted. Properties of a particle. Quantum theory. The photoelectric effects.
In search of more chemistry skills, Prince Philip set off into the dark forest to continue his quest. Along the way, he met Tommy Troll, a large fellow. Tommy told him he knew a lot about chemistry and would teach him 2 more skills.
The first topic that was discussed was about the behavior of light. Tommy Troll said that electrons at their lowest possible energy level are in the grand state.
All atoms emit light when excited by electricity or heat. Electrons at their lowest possible energy level are in the ground state. Electrons that are at 1 or more quanta above their ground state are in the excited state. When an electron loses energy to return to the ground state, a photon of light is emitted. Tommy included a diagram about the atomic emission spectra for Prince Philip to look at.
Prince Philip then asked Tommy Troll, "What is atomic emission?" Tommy Troll replied, "Atomic emission is the passing electric current through the gas or vapor of a pure substance that causes the substance to emit light. In this process, electrons and atoms of the substance are excited, but quickly return to the ground state. If we pass this light through a prism, we get a distinct color pattern unique to that substance. All elements emit light in unique, distinct patterns of visible light called atomic emission spectra. The spectrum corresponds to energy value, quanta, of electron energy levels. Spectra can be used to identify an element."
Prince Philip had been taught much by now, but could not remember everything he was supposed to have learned. By now, Prince Philip had grown upset and discouraged with chemistry and started to wander further into the forest on an angry prance.
After a few hours of mad pacing, a creature with wings appeared. It was the fairy godmother. The fairy godmother saw startled Philip and told him, "Do not give up on chemistry. If you improve your chemistry skills, you can win the beautiful princess of the land far, far away." Then she told him, "I will teach you 3 more things, but I need you to follow."
Before Fairy Godmother taught Prince Philip about the quantum model, she showed him some diagrams. On 1 energy level, there is 1 sublevel. On 2, there are 2. On level 3, there are 3. On level 4, there are 4.
Fairy Godmother taught Philip that the quantum model identifies each electron's position in 4 places. Number 1, the energy level the electron is in. There are 7 possible energy levels to an atom. They roughly correspond to periods on the periodic table. Number 2, the sublevel within the energy level. Sublevels correspond to a block on the periodic table. Number 3, the orbital within a sublevel. 1 orbital holds 3 electrons. The 4 sublevels have different shaped orbitals and different numbers of orbitals per sublevel. Number 4, the spin of an electron. Electrons in the same orbital must have opposite spins, clockwise, counterwise. Sublevel S, the shape sphere. Number of orbitals, 1. Max number of electrons, 2. Sublevel P, shape dumbbell. Number of orbitals, 3. Maximum number of electrons, 6. Sublevel D, shape clover. Number of orbitals, 5. Maximum number of electrons, 10. Sublevel F, shape daisy. Number of orbitals, 7. Maximum number of electrons, 40.
Fairy Godmother showed Philip these diagrams before teaching him about the Lewis dot structure.
Then Philip asked about the Lewis dot structure. She told him that this is a way to draw how valence electrons surround an atom. She said that you have to write the symbol of the element, determine the number of valence electrons of the atom, draw dots around the symbol to show valence electrons. 1. Draw a dot to the right of the symbol for the first electron. 2. For each additional electron, continue around clockwise adding a dot at each position, bottom, left, top. 3. Restart at right, pairing the electrons one at a time. 8 is the maximum number of valence electrons an atom can have. Only draw Lewis dot structures for representative elements. Elements in the same group have the same Lewis dot structure.
Last but not least, Fairy Godmother told him about the electron configuration. This is a way to express complete electron arrangement around an atom, said Fairy Godmother. It is governed by 3 rules. 1. A Baku principle. An electron occupies the lowest energy level possible. 2. Hund's rule. Orbitals of the same sublevel are each occupied by 1 electron before any orbital is occupied by a second electron. All get 1 electron before anyone gets a second electron. 3. Pauli exclusion principle. An orbital can hold 2 electrons. In the same orbital, electrons must have opposite spins.
Fairy Godmother showed Prince Philip some examples. Number 1. Potassium. 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Number 2. Copper. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. Number 3. Bromine. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5. How do you check? Total of superscripts equals electrons, which equals the atomic number in an atom. Sodium equals 1s2, 2s2, 2p6, 3s1. Atomic number equals 11. Or, the last segment of an electron configuration identifies location of element on the periodic table. 3s1, third energy level, s sublevel, 1 electron.
Then Fairy Godmother told Philip, "You have improved your skills enough and you should be proud of yourself. Now go to the land far, far away and win the princess." After running for 12 straight hours, Prince Philip finally arrived at the castle, but the guard stopped him and would not let him in until he learned 2 more chemistry skills. "I will teach them to you," said the guard.
The guard taught that noble gas configuration was an electron structure of an atom or ion in which the outer electron shell contains 8 electrons, corresponding to the electron configuration of a noble gas, such as neon or argon.
What is noble gas configuration? The answer: a short way to write electron configuration in which a noble gas symbol substitutes for a portion of the configuration. Write the electron configuration for neon: 1s2, 2s2, 2p6. Write the electron configuration for sodium: 1s2, 2s2, 2p6, 3s1, or Ne3s1. Above, notice what is the same and what is different. To write noble gas configuration: 1. Write the noble gas that is in the row above the element in the question. 2. Write the electron configuration that follows the noble gas to reach the element in question. Example: magnesium, Ne3s2. Bromine, Ar4p5.
Then he learned orbital rotation was just the notation used to designate the electrons and orbitals of a given element. Example: Na is 1s2, 2s2, 2p6, 3s1.
What is orbital notation? Answer: a graphical representation of electron configuration. Remember, an electron occupies the lowest energy level possible. Orbitals of the same energy levels are occupied by 1 electron before any one orbital is occupied by a second electron. Electrons in singly occupied orbitals must have the same spin. Electrons in the same orbital must have opposite spins. Use lines to represent orbitals. Use arrows to represent electron spin. Group orbitals so that they appear like sublevels. A diagram has been provided for Prince Philip.
"You have done well, Prince," said the guard. "Now go win the princess." Philip was finally allowed inside the castle and frantically looked for the princess far, far away. Through many people, he found his beautiful woman in a face in the crowd and ran to greet her. She saw him immediately and knew why he was here. "I've waited my whole life for this moment," said the princess.
Prince Philip returned home with his princess, and they lived happily ever after.